Hello, my name is Bill Kinney. I'm a professor of math at Bethel University in St. Paul, Minnesota. And this is a second video in my series called Foundations of Arithmetic, Algebra, and Graphing. And there might be a subtitle that I could put to this with an eye toward interpretations and applications in real life. This again is video number 2 about natural numbers, whole numbers, integers, addition, and subtraction, part 2. In this video, I'll focus mostly on the algebraic kinds of properties that we started discussing in the previous video. And if we have time, we'll get to graphical properties. Quick review. The natural numbers again were the counting numbers starting at 1 and going up by 1 every time to 2, then 3, then 4, then 5, then 6, etc. One property I mentioned in the last video is that natural numbers are closed with respect to addition. That means if I add any two natural numbers, 7 plus 11, I will get another natural number like 8. This would be 18. I'm not going to get a non-natural number like 17.5 or something like that. I also won't get a negative number or 0. On the other hand, the natural numbers are not closed with respect to subtraction. Not closed with respect to the operation of subtraction. For instance, because 7 minus 11 is negative 4, and negative 4 is not a natural number. The whole numbers, we again include 0. They are closed with respect to addition, and also again not closed with respect to subtraction. The integers are different though. Again, the integers include the negative numbers, negative whole numbers you might say, going on forever in both directions. They are closed with respect to addition, just as the natural and whole numbers are, but they are also closed with respect to subtraction. You should remember that if you, for example, take 7 and subtract a negative number like negative 4, the rule is to add the corresponding positive number. 7 minus negative 4 is the same as 7 plus 4, which is 11. There's a good reason for this, which I will hopefully get to a little bit in this video, but certainly in the next one if I don't have time for it in this one. So that's how you subtract a negative number, for example. And because of this, and because of the fact that, for example, 7 minus 11 is negative 4, which is an integer, the integers are closed with respect to both addition and subtraction. One application I mentioned in the first video is to cash flow, an application of negative numbers. Cash flow equals net income minus net expenses. And again, because the integers are closed with respect to subtraction, if both of these quantities are integers, for the net income and the net expenses, then the cash flow will still be an integer. Another thing I want to mention now is that addition or subtraction can really be defined in terms of addition when you take the integers as a given. When you accept negative numbers and 0 as quantities that make sense to you, then you can think of subtraction as being related to addition. How so? Well, for example, 7 minus 4 can be interpreted, can be defined, if you like, in terms of addition once you accept the integers as a given as 7 plus negative 4. 7 plus negative 4, both cases they give you 3. So, and again, in a sense, this is 7 minus 4 is being defined to be 7 plus negative 4 once we, in a sense, believe the concept of a negative number to give you 3. That might not seem like a big deal, but it is a big deal. And let me highlight it in another way. Another property that addition has that I want to mention now is that it satisfies something called the commutative property. 7 plus 4 is 11, and that's the same as 4 plus 7. But subtraction does not. 7 minus 4 is 3, but 4 minus 7 is negative 3. Now that might seem a little paradoxical since I said that subtraction can be defined in terms of addition. How does that work then? Why is subtraction not commutative? Well, let's think of 4 minus 7 in terms of addition. This is the same as 4 plus negative 7. And the reason you don't get the same thing is that you really are adding two different things in these lines. In doing 7 minus 4, you are really doing 7 plus negative 4. On the other hand, in doing 4 minus 7, you are really doing 4 plus negative 7. It's a different addition, giving you a different number in this case, 3 and negative 3. What about other kinds of applications? And what's the relevance for other kinds of applications? We'll go back to the height example right here. Again, here's the ground. Here's a hole in the ground. You're standing right there with a ball. You're going to throw the ball up, let it fall back down. As far as keeping track of the position of the ball, that's in the previous video I mentioned that negative numbers are useful. And let's use our imaginations. Let's pretend we do this experiment of throwing the ball up, and initially the ball goes from wherever you let go of it, and let's say you let go of it at height positive 3 feet. If it travels upward, first by 4 feet, and then by 2 more feet, then the sum of those numbers will be the total change in position. In this case, the same as distance traveled. If it starts at 3 feet high, it goes up 4 feet to 7 feet high, that would be 4 feet right there, and then goes another 2 feet up. 6 will be how much it has changed its position. And its final position will be at height 3 plus that change in position. 3 plus 6 equals 9. When it's traveling down, if you want to find the new height after that point, you can think of that in terms of subtraction, but you can also think of it as addition of negatives. For example, it's up at height 9 right now. Let's say now that's the top of its motion, and now it starts coming back down. If it goes down by, say, 5 feet after a certain amount of time, you can figure out its new position, if you like, by either doing 9 minus 5, or you can think of it as 9 plus negative 5. So in this case, in this particular application, you're thinking of adding either a positive or a negative. You would add a positive if it goes up, and you'd add a negative if it goes down. In the end, it would be at position 4 feet high if it is at the top at 9 feet and it goes down by 5. This equation can be interpreted as saying it's 4 feet high after it has fallen down another 5 feet. This will lead us in the next video to thinking about addition and subtraction in terms of the number line. And the number line is very important for graphing, and you want to make sure you really understand the number line for when we get to graphing.